In these notes, we're going to look at solving a system of equations by graphing. And so our goal here today is to find where two equations intersect. Okay, the solution to a system of equations is a point that makes both equations true. So when we talk about a system of two equations, two linear equations, these are going to be two straight lines, and their solution, the solution to the system, is the one point where they intersect each other. And it's pretty straightforward. We're just going to put both lines on the graph, see where they intersect, and that's going to be our solution. So for our first line here on example A, we have 2x minus 1. So that starts at negative 1. We're going to go up 2 over 1, or down to left 1. Just like that. And for our second line, which I'll do in blue just to help us keep track, we're starting up here at positive 4. We go down 1, right 2 for a negative 1 over 2 slope. And there is that line. And we can see they intersect right here at this point, which is the point 2, 3. And that is our solution. It's always a good idea just to mentally confirm that our solution is correct by putting 2 in for x and 3 in for y. And you don't always have to do this, and definitely don't have to write it down, but you should do it in your head. So if I do this up here, 2 times 2 is 4, and 4 minus 1 is 3, so that equation works. And for the second one, 2 times negative 1/2 is negative 1, plus 4 is 3 as well. Right, so if you mentally confirm that your point works for both equations, you can be pretty sure you graphed things correctly. The second one, we got negative 1x plus 2, so that starts here at 2, down 1 over 1, just like this. And then we have the equation 1/4 x minus 3. Oops, I guess I didn't mark that one. Which starts at negative 3 and up 1 over 4. Like this. And these do intersect at a nice point here for negative 2. Not every system of two equations intersects at a point with nice integer numbers, but for the purposes of kind of understanding how this works, typically all of our solutions will be integers because it's just really difficult when you're graphing as a way to solve. If you're graphing by hand especially, it's really difficult to tell where those fractions are if it happens to intersect at a fraction. So we will almost exclusively deal with integer solutions when we're graphing systems. Example C, now this first equation says y equals negative 3. Remember, when there's no x in the equation, the slope is 0, which means we go to negative 3 and draw a horizontal line. So every y value on that line is negative 3. Our second line starts up at 6. We have a slope of negative 3 over 2. And we just made it. So our solution here, 6, negative 3. All right, let's keep going. We've got y equals 4. Again, that's a horizontal line with a slope of 0 through 4 on the y-axis. Now this next one, what says x equals negative 2, this is this line does not have a slope. X equals negative 2 goes through the x-axis at negative 2 and is a vertical line. So it's the one example where the slope and everything doesn't quite work the same way. We can't really write that in slope-intercept form just because of the nature of that line. So the solution, though, is just negative 2, 4. And if you notice, that is the same set of numbers that we get from right here. if every y value on the red line is 4 and every x value on the blue line is -2, they have to intersect at the point -2, 4. So important there to just remember what these two lines look like and which one is horizontal, which one is vertical. And just remember, when it's y equals, you go to the y-axis and draw through it. And when it's x equals, you go to the x-axis and draw through it. So don't draw along the axes, draw through them. All right, the next problem here, example E, we got y equals -2/3 x plus 1. So start at 1 on the y-axis. Then we'll go down to right 3, or up to left 3. Always good to go backwards, especially when you're graphing to solve a system. It's a good idea to go all the way across the graph as far as you can. That way you get a nice set of points so you can really see where your two lines intersect. We have to solve this next one for y, so we'll subtract 2x from both sides. 3y equals -2x plus 12, so divide by 3. And we get the equation y equals -2/3 x plus 4. Well, if we graph that, and we can see already they have the same slope, so we know from our previous set of notes that lines with the same slope are parallel. So these happen to be parallel lines. And our solution to a system is the point where they intersect. So there is no solution here because there is no point where they intersect each other. Parallel lines do not intersect, and so they have no solution. There is no point that makes both of these equations true because they never intersect. Let's go on. We have y equals 3x minus 2. So it starts at -2 and goes up 3 over 1, or down 3 left 1. And our second line, again, we have to solve for y, so we'll just divide by 6 this time. So y equals 3x minus 2. Notice this is the exact same line as the previous one. It goes on exactly the same points in exactly the same spot. These are the same line. And so these, although they're technically the same line, they are two separate equations in our system. And so this system has infinite solutions because these two lines intersect infinitely. They are the same path. And so any point that works for one will work for the other. And so there are infinite solutions to that system. So those last two here, these are the special cases to watch out for. Parallel lines have no solution. If they're the same line, they have infinite solutions. All other types and situations you'll see where they intersect one time, they will have one solution each, and it's the point where the two lines intersect.